Hello everyone, welcome back to my channel. Today we'll talk about VPN technologies and cryptography in VPN. So let's get started. We'll talk about what is VPN. We'll start with the introduction, then we'll talk about what are the different types of VPNs, then we'll also discuss about the cryptography used in VPN. So starting with what is VPN, if we break it down, VPN, which is virtual private network, carries private traffic over a public or shared infrastructure like internet. So virtual here means a logical network. Private means it provides privacy provided through CIA, which are the three elements of cryptography, that is confidentiality, integrity, and authentication. So it provides privacy through cryptography. Then network, which is an interconnection of devices to share information. That's what virtual private network is. So virtual private network secures or protects the data that is transmitted over internet from man-in-the-middle attacks. It is a technology that creates a secure encrypted tunnel for your internet traffic or your private traffic passing through the internet. It shields your online activities from prying eyes and mask your location. So by these ways, it protects the data, the private data that is being shared across the internet, that is the public infrastructure or public network. So what is VPN? As a recap, it provides a secure data transfer. It creates encrypted tunnels through public networks, ensuring sensitive data remains private. Then it provides confidentiality for, and it provides the protection to the data through confidentiality, which means that all traffic is encrypted and prevents eavesdropping. That means man in the middle, even from the unsecured networks like internet. So only the sender and receiver sees the plain text data, whereas everyone else over the internet, if tries to steal the data or any attacks happens, it will only see encrypted data. And it is a security foundation, so it forms a cornerstone of modern network security and privacy strategies. It provides defense in depth. Defense in depth means utilizing different combinations of security protocols and technologies to provide utmost and maximum security to your network. So VPN uses defense in depth, different types of security protocols and technologies to protect the private data passing across the internet to share the information between different sites of the enterprise, different remote users working from home, accessing the resources and the enterprise infrastructure of the corporate. Now, why do we use VPN? First of all, we use VPN because when we are using internet, now internet is a very common platform these days for everyone to share information. But there lies a lot of insecurity towards the data being shared because internet is a public network and is very unsecure to share the data without any privacy and security. So VPN provides that protection for the private data to be shared. So it shields your data from any surveillance, maybe government or any private or any individuals or any attackers and internet service provider monitoring as well. Public Wi-Fi security. It encrypts your connection on unsecured networks like if you're working from cafe, airports, hotels, accessing your enterprise network resources. So it protects your data on public Wi-Fi networks. There is content access. It bypasses the geographic restrictions to access the region locked streaming services and websites. That's also where VPN is used. Then some other use cases of VPN are there are two types of VPN, we can say, based on deployment. Now, based on deployment, there are two types of VPNs, that is site to site and remote access VPN. Now, in site to site VPN connects the entire network together used by the businesses with multiple locations. For example, you have a headquarter, enterprise headquarter, and different branches. So connecting a headquarter to branch is site-to-site VPN. Multiple branches can be connected to the headquarter as well through site-to-site VPN. Then remote access VPN, this is for connecting individual users like the remote workers or users who are working from home or different locations over the internet to a remote network. It is popular for personal use and remote work. Now, as we talked about the VPN use cases or VPN types, so in VPN types, we have talked about VPNs based on deployment. VPNs can be based on OSI. VPNs can be based on technology. Now, as we talked about the deployment type, in the deployment, we have site-to-site VPN and remote access VPN. These are the two VPN types based on deployment. When we talk about OSI model, we talk about the layers here. So based on the layers on which the VPNs functions, we have layer 2, layer 3 VPNs, we have layer 7 VPNs. Layer 2 VPNs like frame relay, MPLS layer 2 VPNs, layer 3 VPNs like IPsec, MPLS layer 3, layer 7 like SSL, TLS VPNs. Then based on technology types, we have IPsec, we have SSL or TLS VPNs, we have MPLS, frame relay, layer 2, hybrid VPNs. Hybrid VPNs, which use the combination of multiple technologies together. So coming back to the deployment, we will talk about the VPN types based on deployment here. Site-to-site VPN and remote access VPN. Now, modern enterprises rely on the VPNs to securely connect the distributed teams and locations. So this presentation will show you the critical differences between site-to-site and remote access VPN. So first, let's talk about the site-to-site VPN. Now, what is it? A site-to-site VPN is a permanent encrypted connection linking two or more private networks across the internet, like a branch and a headquarter. It creates a unified network experience across the geographically separated locations. Like I said, the headquarters, branches, and different branches together. That's what a site to site VPN is. Okay, so different components of this connection are one location connecting to the other location via the internet. That's where we configure a VPN and create a tunnel between the two locations so that the private data that is passing across location 1 to location 2 via the internet is secured. Now, site to site VPN, it is an extension of the classic WAN. If you know classic WAN, which was like the leased lines or frame relay connections. Now, these are the classic WAN connections to which an extension is site-to-site VPN. Site-to-site VPN connects the branch offices to headquarters. There is no client software required, and the VPN gateways that we use here are like Cisco iOS XC routers. We have Cisco ASA, Cisco Secure Firewall, or firewall threat defense. These are the various different gateways used. Now, these gateways provides what? These gateway provides encapsulation and it provides encryption. And vice versa, it provides de-encapsulation and decryption also at the receipt. One protocol that is being widely used in site-to-site VPNs is IPsec. IPsec is the protocol of choice used in the site-to-site VPNs. This is a standard protocol defined by IETF, Internet Engineering Task Force, which is a framework of different protocols. It is a framework of protocols like ESP, AH, IKE, Now, these are different protocols used for different purposes. ESP is an encapsulation security protocol, works at layer 3. AH is authentication header working at layer 3, and IKE is internet key exchange, which works at layer 4. So site-to-site VPN uses public IP addresses on both sides of the VPN tunnel, and ESP, out of the framework of the IPsec, is the protocol of choice used in the site-to-site VPNs. Now, how site-to-site VPNs work? There is a connection establishment. VPN appliances at each site authenticate and negotiate the encryption parameters and hence forms a secure tunnel. Then there is traffic encryption. So data packets that passes across the tunnel are encrypted before leaving the source network. And at the receipt, at the exit interface of the gateway, it is being de-encrypted. There is secure transmission. Encrypted data travels through the public internet in a secure tunnel. So there is no man in the middle, or the data could not be readable. So there is security through confidentiality. The data is encrypted. So only the authorized users can access and read the data. There is decryption and delivery. At the receiving VPN appliance, the VPN gateway or the appliance decrypts the traffic and forwards to the local network device. So what are the benefits of site-to-site VPN? The benefits of site-to-site VPN are enhanced security. All inter-site traffic is encrypted, protecting sensitive data from interception. Simplified architecture. There is a unified network policies and streamlined access control across all locations. Cost saving. It is much more affordable than the dedicated lease lines which were previously used like WAN connections. So while maintaining the security of the network using site-to-site VPN, you save cost. Rapid deployment. And there is scalability to that also. So new locations can be integrated quickly, new users can be added without extensive infrastructure changes. No underlying infrastructure changes needed there, but you can still add new locations or new users. So rapid deployment or scalability is there. Now, some common site-to-site VPN use cases are you use it in corporate WANs, so to securely connect the headquarters with multiple branches, data centers, warehouses, that's where site-to-site VPN is configured. Mergers and acquisitions quickly establish secure connections between merging companies' networks during integrations. Global operations, it enables the seamless communication for organizations with the international presence and teams. So these are different use cases of site-to-site VPN. Now, before we move to the remote access VPN, let's talk a little bit more about the site-to-site VPN. That is, in site-to-site VPN, on the two sides, the gateways we can use can be router or firewall. So router or firewall can be used as the VPN gateway. Now, what are the benefits of using a router? The router is better in terms of versatility. So it provides versatility. It can be also used as a benefit in integration. So integration here means integration with network services or protocols like GRE. Whereas firewall is used for security focused things. For example, if let's say the focus is security where you have to enhance the packet inspection, so deep packet inspection is there. There is AVC. AVC here means application visibility and control, and IPS, intrusion prevention system. So these are the various ways by which we can configure site-to-site VPN. So in a site-to-site VPN, it can be configured through many possible configuration types, like router to router. We can configure router to firewall on the two ends of the VPN, firewall to firewall, or Cisco firewall to a third party firewall. Now, these are the different configuration types. A static IP is configured on both sides. Okay. Now let's move ahead and talk about the remote access VPN. So when we talk about remote access VPN, In the past, remote users used dial-in networks or ISDN. With VPN users, you need just the internet to connect to the headquarter. A VPN client is used by the host in the remote access VPN. Today, the VPN client used is Cisco Secure Client, which was formerly called Cisco AnyConnect. Okay, this is the old name. This is the new name or the new version, we can say. Okay, so what is remote access VPN? This is a secure connection allowing individual users or hosts to access a private network from anywhere, like the remote users. It creates encrypted tunnels from personal devices to the organization's networks. It provides user authentication. So the employee logs in with the secure credentials, often using multi-factor authentication. So that is how authentication is provided. There is tunnel establishment. VPN client software creates an encrypted connection to the company VPN gateway and secure access. So the user gains the protected access to the internal resources as if the physically presented resources. So these are the various different benefits of using remote access VPN. Now, in remote access VPN, the VPN gateway are either in Cisco, we have Cisco ASA or Cisco Secure Firewall or Cisco Secure Firewall Threat Defense. Now, either you will have client, a VPN client used by the host, or there is a client less VPN connection also, in which you can access the VPN headend using web browser. So you can connect using the web browser, the normal web browser, but it is not supported on the new or the latest Cisco Secure Firewall or FTD. It is available in ASA only up to version 9.17. That's it. So in the new Cisco Secure Firewall, it is not supported. Clientless VPN is not supported. It is only client VPN. Okay, so talking about remote access VPN furthermore, so there is client used. Now, Cisco Secure Client, which I mentioned, is used here. It uses IPsec, IPsec ESP protocol for encapsulation with IP transport mode, or SSL or TLS with TCP transport mode. Okay. Now, talking about site-to-site and remote access VPN differences, the connectivity of site-to-site VPNs is a network-to-network, whereas remote access VPN is user or device to a network. So typical users in site-to-site is offices or branches, whereas remote access VPN are individual remote employees. Scalability in site-to-site VPN is best for the fixed sites, whereas remote access VPN is best for mobile or flexible users. Some example usage of site-to-site is corporate WAN interconnection, and remote access VPN is for work from home access. One more thing I want to add here is when we talk about the site-to-site VPN, there are two modes through which we can configure the VPN, and the two modes are tunnel and transport mode. The tunnel mode adds header, whereas the transport mode modifies the header. Like if we are using a router to router configuration here, you will use GRE. GRE is generic routing encapsulation, which is an encapsulation protocol used as a tunneling protocol, which supports dynamic routing and it supports multicast, but it does not support encryption. So a solution to overcome this limitation is we use IPsec over GRE. Okay, so the solution is IPsec over GRE or IPsec over VPN. So the problems with GRE is also extra overhead, the solution of which is changing the tunnel mode, which adds the header to transport mode, which modifies and uses the existing header only without adding a new header. Okay, so the difference in these modes are that tunnel mode adds a new header, whereas transport mode uses the existing IP header instead of creating a new one. Okay, so like here in the GRE also, GRE creates headers for tunnel endpoints, whereas IPsec, when used in combination to it, uses the same header as in the transport mode. Okay, and in remote access VPN, a client is used. So the client is Cisco Secure Client, which access or establish a connection to the firewall head end from the outside using IPsec or TLS. Now, different types of tunnels can be created in remote access, that is DTLS or TLS. DTLS tunnel is datagram TLS, which uses UDP, whereas the TLS is TCP and carries the TCP traffic. So the TCP tunnel is established for TLS, and for DTLS, a UDP tunnel is created. Now, in case of DTLS tunnel, there is a process. The process goes in a step-by-step order, where the first thing is a TCP TLS connection is built. So when we are talking about DTLS, TLS is still built. So a TCP TLS connection is established, which is also for the failover. Then a UDP DTLS tunnel is created by negotiation from the client. If that negotiation is successful, the traffic flows from the DTLS tunnel except for all the control packets which passes through the TLS tunnel. If the negotiation fails, the traffic continues via the TCP TLS tunnel as a failover. Or if the DTLS tunnel fails after the setup, the failover to TCP TLS until the DTLS is re-established. Then the client on one end needs to authenticate to connect to the head end of the VPN gateway using the VPN client. The head end will decrypt the traffic on the outside interface and send the decrypted or clear text traffic to the inside network. Now, this is about how site to site VPN and remote access VPN works, what are the different functions and differences between these. If we talk about the use cases of VPN in 2025, it is used for content access, like bypassing the geographic restrictions on streaming platforms or social media, censorship, accessing open internet in regions with information control, remote work security, protecting the sensitive data, business data for distributed workforces. So that is about VPN. Now, uh, we will talk about cryptography in VPN. Now, before that, we will talk about some of the components used in VPN. What are the VPN components? So the VPN components are authentication. Now, authentication here means the VPN peer authentication. In site-to-site VPN, we have authentication through digital certificates, pre-shared keys. In remote access VPN, username, passwords, digital certificates, dual multi-factor authentication, these are used for authentication. So this is the first component for authentication of VPN peers. Authentication can be of device or the user, two types of authentication, device authentication or user authentication. Now, second thing is encapsulation method. For encapsulation method, now user information, how that user information like data is to be encapsulated or transported across the network, that is being taken care of. Then third is encryption. So the data encryption, which solves the eavesdropping issues, that is another component of VPN. Like there are different algorithms which are used for encryption, which takes the user data and a key value and runs that data through the encryption algorithm to get a cipher. Now, these algorithms are like ASA, RSA, DES, different algorithms exist, right? Then next is data or packet integrity. Now, integrity here means making sure that the data is received as it was sent. There was no change in the data. There was no tampering in the data. It was unchanged. So to make sure of the integrity, for the integrity check, there is hashing used. Now, hashing use the checks through the signatures. So there is data, there's shared key, and some hashing algorithm is run over these data and the shared key to create a hash, which is an output, a fixed output, and it is an irreversible process. By reversing that process, we cannot generate the data, but we get a one-way fixed output, which is compared at the receiving end, and if the hash or that output match, it confirms the integrity. Different algorithms for hashing also exist, like SHA-1, SHA-2, MD5. Different types of integrity algorithms are there, which are called hashing algorithms. Then next is key management. Because we are talking about the keys here, we have key management, which makes sure how the keys are derived, whether the keys are static or dynamic, whether it would be randomly generated, dynamic keys, or what is the frequency of generation of the keys. All that comes under the key management. Then we have non-repudiation. Non-repudiation means the proof of the communication, which provides the authentication and accounting of the transaction or any communication which has taken place. So it proves that the communication is successful and the communication has taken place. Neither the sender or the receiver can deny it. That is non-repudiation. Then next is application and protocol support. Okay, which determines that what type of traffic needs to be protected. That is IP traffic, TCP, UDP, ICMP, all of that, different types of applications or protocol and the traffic. Then after that, we have address management. In address management, it overcomes the issues with the remote access connections. So that's where we take care of the address management. Address management can be an issue in the case of remote access VPN, especially when the remote users or the remote users who are working from anywhere or from home using different Wi-Fi connections or different internet connections or from cafes or different locations are using different IP addresses. So we cannot have a track of all the IP addresses. So that's where address management can be one issue. So that has to be addressed. And this all comes under the VPN component. So these are all different components that are the part of VPN infrastructure, working, and the processes of VPN. Now we'll talk about the cryptography used in VPN. So when we talk about cryptography, cryptography is an art and science of securing the information by transforming it into a form that unauthorized users cannot access. So cryptography uses a technique or techniques of CIA, that is confidentiality, integrity, and authenticity. Confidentiality is encryption, which makes the data unreadable to anyone without the proper keys. Integrity is the hashing, which ensures that the data hasn't been tampered with within the transit. Authenticity is digital signatures, which verifies the identity of all parties in the connection. So these are the three different techniques used in cryptography to make the VPN work securely and secure and protect the data. Now, some core VPN cryptographic concepts are the use of keys. There is key exchange, there is authentication, encryption. We have talked about different algorithms used for that. So we have different algorithms here you can see for key exchange, for encryption. Then authentication is a process which we know to is to verify the identities of the parties connecting, like servers, clients, to prevent man in the middle. Now we have two types of encryption. When we talk about confidentiality, we talk about encryption. So in confidentiality or in encryption, we have two types of encryption, that is symmetric and asymmetric. Symmetric encryption is the method of encryption with same key used for both encryption and decryption. The information is only accessed by those who have the shared secret key. It is stronger, it is faster, it is more efficient encryption type. It is well suited for large data. And the most popular algorithm used for encryption is AES. which is up to 256 bits, which create a key size of up to 256. Okay, so that is about the symmetric encryption. So it is the industry standard for VPN data encryption, extremely secure with proper implementation, hardware acceleration on modern devices, and widely vetted by the security researchers. When we talk about asymmetric key cryptography, it solves the problem of key management. So, asymmetric key cryptography is basically used for key management, sharing, changing keys. It's also known as public key cryptography. It uses a pair of keys. So, the pair of keys used here is private and public. Whereas one key is used for encryption, the other is used for decryption. Public key is used to do the encryption, which is given to everyone, whereas private key is kept private and is only used for decryption by the party who's having the private key for that decryption can only decrypt that data and can read that data. Whereas for digital signatures, private key is used to encrypt and public key is used to decrypt. It's just the opposite of how the asymmetric key cryptography works, which is public key used to encrypt and private is used to decrypt. Digital signatures, which also authenticates the data and the integrity of the data is checked through the digital signatures. So a digital signature is created by encrypting through the private key and decrypting through a public key. So both symmetric and asymmetric keys can be used for different purposes. Now, different algorithms used in asymmetric are RSA, ECDSA, ECC for Cisco specifically. Then, in cryptography, cryptographic agility is known. So, there is future proofing VPN security. Cryptographic agility, this is the ability to quickly swap the encryption algorithm when vulnerabilities are discovered. So, the modern VPNs implement modular design that allowed rapid security updates. Now, vendors focus on developing VPN stacks that can adapt to the emerging threats. We have talked about the different cryptographic methods like confidentiality, where encryption is used. Two types of encryptions are symmetric, asymmetric. Another key concept or cryptographic technique is integrity. Now, in integrity, integrity means making sure that the data is unchanged. That's where hash value is used or hash function is used or digest is created, which is a one-way function. Okay. The primary feature of a hash function is something called avalanche effect, which means that even a minor input change will produce a significantly different output, which will cause the hash to be generated differently when it is received. So the integrity check is ensured there. So hashing is also combined with something called HMAC. Now, hashing is very secure, it performs the integrity, but there is no protection towards man in the middle. So HMAC is combined with hashing to make it more secured and making integrity foolproof. So HMAC is hashed message authentication code. So with hashing, the problem could be man in the middle, whereas HMAC combines hashing with the secret symmetric key to produce this unique hash. Just a moment. Right, so we were talking about this HMAC here. HMAC combines hashing with a secret symmetric key to produce a unique hash value. User authentication is performed here. Okay. Next, we have digital signatures. Digital signatures are used to sign a document and it generates a hash and encrypts the hash using its private key. That's what a digital signature is, and that is added to the document. The receiver will then generate the hash and decrypt it using the public key and compare it with the received hash. Okay. Authenticity is checked by this, and that ensures non-repudiation. That means also it ensures that the party cannot deny the authenticity or the transaction or the communication. Primary use of different key types that we talk about, public, private, the different keys we use here or key functions are for encryption, integrity, and authenticity or authentication. Okay, so these are the different components we use. Now, VPN authentication mechanisms can be through authentications like username, password, basic authentication, which is still common, but increasingly paired with additional factors to make it more secure, like digital signatures. Certificate-based authentication methods, where digital certificates are used, which I just talked about, what are digital certificates, which verifies the identity more securely than the passwords alone. Multi-factor authentication is used, which combines something you know, you have, and you are for the maximum security, right? Which we commonly use nowadays. Some VPN security threats in 2025 are AI-powered attacks, machine learning system targeting the VPN infrastructure vulnerabilities, state actors, government-sponsored efforts to compromise the VPN security and insert the backdoors to enter the VPN. Protocol flaws, zero-day vulnerabilities, the vulnerabilities that are not very common, that you're not aware of in the implementation, and that can compromise the security. Configuration errors, improper setup leading to the security gaps, even with the strong encryption. These are some considerations you have to take care of, which are the VPN security threats. Then choosing a secure VPN provider. This is also something to consider. Choosing a secured VPN provider. It should be up-to-date cryptography using modern encryption standards like AES or ChaCha20 and protocols like WireGuard, OpenVPN. These are the up-to-date cryptography mechanisms. Privacy policies, true no logs policies verified by independent audits. Transparency should be there. It should be open source clients, regular security audits should be there, clear business practices should be maintained. Performance versus security. There should be a balance between the speed, features, robust encryption for your specific needs. So both the performance and the security should be considered. So, as we've talked about the various different components of VPN, the VPN functions, types of VPNs, and the very important cryptography in VPN. Lastly, the conclusion is the future of VPN security. The key takeaways are the quantum safe cryptography should be used. So, cryptography has become an essential in computing the advances. VPN remains critical for privacy, security, and freedom online. Regular security updates and audits are necessary for threats evolving. Choose the providers with the transparent practices and modern protocols, and the arms race between the privacy tools and surveillance continues to accelerate. Now, we have talked about the various different key components of VPN and the cryptography used in VPN. I hope this video helped you understand the overview of how VPN works and the key parameters of VPN. Thank you for watching.